Hello and welcome to my video. In this video, I will explain to you some steps that you will always do when using supervised learning, whether the tool or programming language that you will use. So, in this video, I prepare the Jupyter notebook that you can download in the description of this video. So, the first step that you will always do is loading dataset. In your case, you will have some CSV or Excel file, but in this case, I'm using Rescaling dataset. Rescaling is Python library that contain many machine learning algorithms that you can use. So if you confuse what machine learning algorithm that you want to use, I think you can try Rescaling. So here I'm choose Irish dataset and diabetes dataset. Irish for classification and diabetes for regression. Here the description of the data. The feature is X, sex, BMI, BP, and etc. This is the variable or the measurement from the patient of diabetes, and the label is some quantitative measure. I don't know what is this, but I think it's related to diabetes. And for the Irish dataset, the feature is the attribute of the flower, and the label is the kind of iris. This is here there are iris setosa, iris versicolor, iris virginica. That is the description of the data. Now here I'm extract the feature and the label, here for the iris and here for diabetes, and I make some randomizer to random the feature and the label. After I random them, I divided the dataset into 4 parts. So I will have train feature, train label, test feature, and test label. The next step is rescaling the dataset. In general, there are 2 techniques that you can use to rescale the dataset. Those are standardization, that using mean and standard deviation, and normalization, that using minimum and maximum of the variable. In this case, I am using standardization that take mean and standard deviation. Here we will rescale all the feature and the label, but in this case, in the case of diabetes data, in the description of the data, they say that they said that for the feature it's already rescaled, so we don't need to rescale the feature of diabetes. And for the label of the iris, it's some class, so we can rescale that. Instead, we will encoding the data. We can use 2 techniques to encoding the categorical data. Those are one hot encoding and label encoding. In this dataset of iris label, it's already label encoded, so we don't need to encode it. In the third step is define the model. So for iris model, of course we will use the classification model, and diabetes we will use regression model. And for iris, I'm using superfactor classification, and diabetes is superfactor regression. Here, when we define the model, we set the hyperparameter. Hyperparameters are needed so our model will perform better. And the next step, we train the model. To train the model, of course, we will use train data. And then we will predict using the trained model. Here for diabetes, there are two steps to predict. This is done because in diabetes level, we already rescale the data, so to find the real value of the prediction, we must inverse the standardization. Here the inverse of the standardization, and here you can look the output of the model. I think iris prediction is good, but in the other hand, for diabetes model, I think it's not too good. And the last step is calculate the model performance. You can use various metric to calculate the model performance, but I think in this case, accuracy and LMSA is enough. But in the special case, like when you find imbalanced dataset, I think accuracy and LMSA is not enough. You must use the special metric like precision and recall. Here the accuracy and LMSA. For the accuracy is 93% good, and LMSA of diabetes 47.7. I think this is not good. So when you find your model performance is not good enough, you must back to the third step. To find the model, you must tune the hyperparameter of the model. After that, fitting, predict, and calculate again the performance of the model until you satisfied with the result. I think that's all the step that you will always use when using supervised learning. If you find that you don't use one of these steps, I think in the tool that you use, it's already automated that step. So when you write the script, you don't need to do that step.